Hello friends, today we are going to learn about the milling operation. Okay, so first is your zigzag facing. Why facing is done? Facing is done to get the uniform surface. Okay, that's why facing is done. So controller is like as usual the Fanuc, and also facing is done to get the exact thickness or exact height of the workpiece. Okay, so this is your profile, which is a square block of 50 cross 50. Square 50 means length is 50, breadth is 50. Okay, so this is your origin. So when this is your origin, it means workpiece is your inverse coordinate. Inverse coordinate means like this. Let's say this is your x-axis, this one is your y, this is the origin. Okay, workpiece is over here. That's why I am saying this is in your first coordinate, which means all the points, all the coordinate of this point will be in positive. Okay. So this is the origin. These are the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So let's find out the coordinate of all these points. Okay. So from here your operation will start. So this is your point number 0. The point number 0 will be minus 15, 0. 1 will be 0, 0, 2 will be 50, 0, 3 will be 50, 10, 4 will be 0, 10, 5 will be 0, 20, 6 will be 50, 20. So it goes like on up to point number 12, which will be in x it will be minus 15 and y it will be 50. Clear? So in milling operation we have three axes, x, y and z. Z is for your tool movement, and x and y is for your bed movement. Okay, so let's say your cutter dia is dia tools. Okay, it's an end mill cutter. So while using this cutter, so cutter top view will be like your circle. Okay. So while using this cutter, the cutter will move from point number 0 to 1 will be like this. Okay. The center point of cutter will be coincide with this line. Okay. The center point of cutter will be coincide with this line. Okay. So the space between from this line to this line is 10 mm. So while using the cutter of dia 12, it will remove metal. When it move like this, it will remove metal from here will be 6 mm, and while from moving from 3 to 4, it will again remove metal from here 6 mm. So like you can see over here, that cutter path will overlap. Okay, cutter path will overlap. So in this way there will be no metal in between. Okay, so let's begin with the program. So in milling program, we first write the homing line, which will be like this. G28, G91, Z0 homing will be in Z axis. G28, G91, then X0, Y0, then 70, G00, G40, G54, G80, G90, G21. Okay, then tool chain M06, T01. Okay, then your spindle split M03S 800. Okay, then we are going to write the coordinate of point number 0. So what is the coordinate of point number 0? Which is minus 15 and 0. So it will be like this: g0 0, x will be minus 15, y will be 0. Clear? Then g0 0, get 5. Okay, then after getting height of 5 mm distance, let's took the coolant M08 in milling. Okay, so after that H1 equal to, let's take 0.5, it will be G01 Z minus H1 F50. This is your plunge line. Okay, it means at this point, by writing this line, your cutting tool will be plunge at this point, which is minus 15 and 40. Clear? Which is about 500 micron. Okay, after plunging at that point, which is minus 50 and y0, then let's 0 to 2 is a straight line, then write it's 0 to 2 is a straight line, then we are going to use g01 for that, and after that write the coordinate of point number 2, which is g01, x will be how much? At point number 2, x will be 50, y will be 0, then we will be cutting feed F500. Okay, then again on 2 to 3, G01, x50, y10, then 3 to 4, G01, x0, y10. Okay, then to 5, G01, x0, y20, then 5 to 6, G01, x50, y20. Clear? x50, y20, then 6 to 7, G01, x50, y30, then 7 to 8, G01, x0, y30. Okay, x0, y30, then 8 to 9, again G01, x0, y40, then 9 to 10, G01, x50, y40. Okay, then 10 to 11, G01, x50, y50. Then again 11 to 12 is a straight line and directly comes to the point number 12, which is G01, x minus 15, y50. Then come to point number 0, G01, x minus 15, y0. So in milling, always complete the circuit. You start from 0, you have to end at 0. Okay, so there is something over here. Then there will be a question in your mind that while doing facing, up to what extent, up to what mm we are going to face, or we are going to remove the material by doing facing operation. Let's say about 5 mm. Okay, we have to remove a 5 mm material from top to bottom. Okay, 5 mm material by doing facing operation. Clear? Then after writing this line, you have to write over here H1 equal to H1 plus 0.2 if square bracket H1 less than equal to 5, square bracket close, go to 50. Okay, then after that take the Z axis and shift to axle, G00, Z5, clear. Then your M5 is your spindle off, M couldn't off. Then homing, G28, G91, Z0. Then G28, G91, X0, Y0. Then your M30. Okay. Your program is not over yet. Okay. So this block is saying something over here. Go to 50. It means you are indicating this line. You are command this line to go to block number 50. Okay. So block number 50 is over here. N50 N50. It will move like from here to here. Okay. It will repeat this program, repeat this coordinate up to till it get the 5 mm. Okay, it will repeat this program till it get 5 mm material here. So let's talk about some points. H1, H is your macros. Okay, so Z minus H1, F50, this is your plunge line. Okay, and F50 is your plunge feed. Then F500 is your cutting feed. So H1 is your first depth of cut, which is 0.5 mm, and H1 equal to H1 plus 0.2 is your incremental depth of cut. Okay, so it will follow this program up to 5 mm. Clear? So this is all about the zigzag facing operation. Your program starts from over here and ends over M30. Clear? So I forgot to write over here is the program number. 0123 4 is the program number. Okay.